Hi guys, so in today's video we're going to talk about accuracy versus precision, and we're going to talk about significant figures, or sig figs for short, a little bit. And it's basically telling you, sig figs, how many numbers or how many digits are in a measurement, and the number of digits in the measurement tells you how accurate the device was that took that measurement is. Okay, so first of all, when we talk about accurate, I feel like sometimes we use the words accurate and precise interchangeably, but they actually mean something different. And if you look at these three dartboards, this kind of goes over nicely the difference between the two. So let me just get my pen out, and we're going to write the definitions for accuracy versus precision. So when we talk about being accurate, when I throw a dart at this board, I want it to land on the bullseye. So landing on the bullseye means that I'm accurate. If we look at the first picture, the darts landed on the bullseye, so the accuracy was good. In my other two pictures, the darts are nowhere near the bullseye, so the accuracy was poor. Now, it's important to understand that you can have poor accuracy, but you can have good precision. And that's why you need to know the difference between these words. So, accuracy, we're going to define as how close your measurement is to the accepted value. So here we're talking about darts and a bullseye. In the lab, we could be talking about something like density. So water, scientists have measured and measured and measured and decided that water's density is 1.0. If I gave you water and asked you to go into the lab and find its density, you would find its mass, you would find its volume. You'd probably come up with something close to 1.0, but it might not be exactly 1.0. So it's how close you are to that accepted value, or the value that we know is true for that measurement. Precision is something a little bit different. So in the first and second picture, our precision is good, and in the third picture, my precision is poor. In the second picture, even though we're nowhere near the bullseye, we can still say that the dart thrower was precise, because every time they repeated their throw, it landed in the same spot. So precision means that you're taking a measurement multiple times, you're doing multiple trials, and every time you get the same answer. Okay, so precision is how consistent results are by doing multiple trials. And guys, when we talk about being accurate and being precise, we can only be as accurate, and our measurements can only be as accurate as the tools we use to get them. So when we do labs in class, we're usually not going to get exactly what the accepted value is, and that's okay, as long as we can talk about error. So what I want you to do right now, I want you to pause this video, and I want you to look at this ruler and this graduated cylinder, and I want you guys to tell me what an appropriate length is for the arrow, and then what an appropriate volume is for the liquid. So pause the video, write down some numbers, and then come back. Okay, so guys, if I look at this arrow, it looks like it's about halfway between 6.6 and 6.7. So I can say that the length is 6.5. If it looks a little bit shorter than that, I can say it's 6.4. If you think it's a little bit longer than halfway, you could say 6.6. The important thing here is that we see that the number that I'm estimating is in the 10th spot. This ruler doesn't have lines for the 10th spot for centimeters, but I'm estimating it based on where that arrow stops. So what's important for you to know here, guys, is that once you estimate one number, you can't go ahead and estimate a second number. So if somebody were to say, well, I think the distance is 6.45, this would be an example of a measurement that is not acceptable. If you're not even sure about the number in the 10th spot being a 4, then there's no way you can determine what the number in the 100th spot might be. So using something like a ruler, measuring to the 10th spot would be an acceptable form for an answer. Here in this graduated cylinder, we have smaller increments. We actually have lines on the tool that measure to the 10th spot. So if my water is in between 1.5 and 1.6, I can say, okay, maybe the volume is about 1.55 or 1.56. This time I'm estimating the number in the 100th spot, which I'm allowed to do. So the rule for using equipment and knowing what decimal place to make a measurement to, you're always allowed to measure one spot past the instrument's scale. Okay, so whenever we do a lab in class, you need to think about what are the increments on this equipment, and I should be estimating one number past those increments, and that's going to help give you the most accurate measurements and data possible. Okay, so now sig figs, like I was talking about before, it's literally like how many digits are in a number. So like for this length here, I have 2 digits in this number, so this has 2 significant figures, where my graduated cylinder gives me a measurement that has 3 significant figures in it. Okay, so the more significant figures you have, the more accurate the tool was that you used to measure and get that number. So if you're just given numbers and not doing the lab yourself, you can look at those numbers and you can make assumptions about how accurate was the tool that was used. Okay, so let's look a little bit more at that. The kind of error or the kind of an uncertainty that can come up when you use equipment is different depending on if it's digital or not. So when it's digital equipment like this thermometer or a scale, if I put something on a scale, numbers pop up. It's not something that I have to read and estimate. So what you do is you look for the smallest division that it reads to. You look for what decimal place the tool reports, and you can go up 1 or minus 1 from there. Okay, so since this scale reads to the 10th spot, the actual temperature in the room can be plus or minus 0.1 because 0.1 is in the 10th spot. So that means even though the thermometer is saying 24.8, the temperature could actually be plus 0.1. So it could be 24.9 degrees Celsius, or it could be minus 0.1. It could be 24.7 degrees Celsius. So that range is what you'd have to be aware of for when you're using something that's digital. If the thermometer read to the 100th spot, you would do plus or minus 0.01. If it read to the 1000th spot, you would do plus or minus 0.001. If it read to the 1 spot, you would just do plus or minus 1. So you're just taking that last number and you're making it go up 1 or down 1. So that's nice and easy, and that's the rule for digital equipment. Analog equipment is a little bit more difficult because you have to remember that when you read something like a ruler or a clock, the last number in your reading is always an estimate. So you don't want to look at the number that was estimated. You want to look at the number before that. You want to look at the number that you're sure of. You want to look at the smallest division that's actually a line on your tool. So if I look at this clock, those little lines on this clock represent seconds. So that 0.6 that's there, that's an estimate. I want to look at the spot that wasn't estimated, which is the 1 spot. So once I figure out that the number that wasn't estimated in here was the 1 spot, I want to cut that in half because I have to do plus or minus half the smallest division. So 1 second is the smallest division on this clock. And if I cut that in half, I get 0.5. So my uncertainty here would be plus or minus 0.5. So 20.6 could either be plus 0.5, so it could be 21.1 seconds, or it could be minus 0.5, so it could be 20.1 seconds. So the big difference with the analog equipment, you don't look at the last number, you look at the number before that, and then you have to remember to cut it in half, which we did not have to do before. Okay? What I want you guys to do is take a look at this triple beam balance. I want you to take a look at this ruler. And I want you to take a look at this triple beam balance. And I think this is the last one, this graduated cylinder. I want you guys to make a measurement, and I want you to decide what the error is, plus or minus. Now, if you look at all of these, none of these pictures that I just showed you are digital. So when you do your plus or minus with your error, you have to remember that you're looking at the number that's second to last, and then you have to cut it in half. All right? So give that a try, and then we'll talk more about this tomorrow.